Hello, people. Welcome to today's math class. Today we have this nice question before us here. The question is how to solve x to the power of 6 plus x to the power of 5 equal to y to the power of 2 minus 4. Here we said find all integer solutions of x and y, only the integer solution. So this is my progress. If you've not subscribed, subscribe because here we drop at least a video every day for our learning. Alright, so let's take our selection. Okay, so the question here is this. So here we're having y to the power of 2, and here we have 4, so we can express this 4 as 2 to the power of 2 because we're trying to bring out the difference of 2 square into this system here. So this is going to give us our x to the power of 6 plus our x to the power of 5 equal to y to the power of 2 minus 2 to the power of 2. Now recall the difference of 2 square. We say that if you have your a to the power of 2 minus b to the power of 2, this is equal to our a plus b bracket a minus b. Okay, so with this we can rewrite our expression here. So this is going to give us our x to the power of 6 plus x to the power of 5. This is equal to our y plus 2 bracket open here, our y minus 2 bracket. If you look at the left hand side of the expression, we can factor out x to the power of 5. So let's go ahead and do that. So this is going to give us x to the power of 5 bracket. If we use this to divide this, we are left with x plus. If we use this to divide this, we are left with 1. Everything equal to bracket y plus 2 close bracket into our y minus 2 close bracket. Okay, so what are the conditions we have to look at here now? From this expression we have here now, we discover that if y is odd, then y plus 2 and y minus 2 are both odd. And if y is even, then y plus 2 and y minus 2 will also be what? Even too. Will be both even. Again, what if our x is odd? Then x to the power of 5 will be odd. But x plus 1 is even. And if x is even, then x to the power of 5 is even and x plus 1 is odd. Therefore, x to the power of 5 and x plus y can never be equal to our y plus 2 or y minus 2, except when the terms are both 0. So what we do here now, so we use a system that will enable us to get our even to even and odd to odd. So here we're going to take case 1. So let's take here case 1. What is our case 1? So when x to the power of 5 is equal to 1, then we're going to have our x plus 1 will now be equal to bracket y plus 2 plus bracket to our y minus 2. You get that? Okay, so from here, let's separate this. So if we want to make our x the subject of the formula, so our x will automatically give us what? 1 here. So let's hold this now. Then we come to this side of our equation. Here we have our x plus 1 and we find our x to be 1 here. So we add this to here. So this is going to give us here our 2 is equal to, we can open up everything here. So if we open up this, it's going to give us y minus 4. Okay, so automatically we're going to have here y is equal to our 4 plus 2, which is equal to 6. This is our y square rather. So we have square there. So if we have to look for our y will be equal to what? Square root of 6 plus minus the square root. So if you look at this, here we don't have integer solution from here. So from the whole of this, no integer solution. We can say no integer solution from this. All right. So this one is discarded. This one is so we take our case 2. So let's look at case 2. If we're going to get an integer solution from there, so our case 2, we're going to have our x plus 1, right? Putting it to what? To 1. Then therefore our x is equal to 0. Then on this other side, we're going to have our x to the power of 5 will now be equal to our y plus 2 bracket our y minus 2 close bracket. So if we go ahead to open up, again we have our s to be 0, so this is going to give us 0 is equal to our y to the power of 2 then minus 4. So we have y squared will now be equal to 4. We take the square root of both sides, so and this these are plus minus, so this leaves. So have our y will now be equal to plus minus 2 from here. So the pair of solution for case 2 is going to give us here, therefore our x comma y will now be equal to have bracket between 0 comma plus minus our 2 close bracket. So this is an integer solution, so this one is accepted. Okay, so we'll go to our case 3. Let's look at case 3. If we're going to get something good from there, we have here case 3. In our case 3, we're going to have our x to the power of 5 now be equal to minus 1. So if we have this to be minus 1, we take the fifth root, so x is automatically going to give us minus 1. Then on this other side, then we're going to have this to be x plus 1 will now be equal to bracket our y plus 2 close bracket our 2 minus y. You get that? Right. So if we substitute a minus 1 into this, we're going to have minus 1 plus 1 is equal to, if we open up this, we're going to have minus y to the power of 2, then plus our 4. Again, if you look at this, this is going to give us 0 is equal to our minus y squared plus 4, which is going to give us y to the power of 2 is equal to our 4. So if we square both sides of the equation, this is going to give us our y will now be equal to, sorry, taking the square root of both sides of the equation, this is going to give us the square root plus minus 4. So this is going to give us here our y will now be equal to plus minus 2. So what are the pairs of solution to our case 3 so far? So we're going to have our x comma y now be equal to bracket minus 1 comma plus minus 2. Again, this is an integer solution, so this is also accepted. So let's look at case 4. We have case 4. Let's also see if case 4 will give us something good here. So here we're going to have our x to the power of 5 equal to our bracket y plus 2 close bracket 2 minus y close bracket. So if we open up this here, it's going to give us our x to the power of 5, then equal to everything we have here. If we use this to open up this, is going to give us minus y to the power of 2 here plus our 4. So how do we solve for our y in here? We consider the other side of it now. Then we're going to have x plus 1 equal to minus 1. So this is going to give us x equal to minus 1 minus 1. We have x is equal to minus 2. So we have our s to be minus 2. So let's come back to this side and put in this value here. So I have here minus 2 r to the power of 5 is equals to minus y to the power of 2 plus 4. And this will give us minus 32 is equal to minus y to the power of 2, then plus 4. So if we rearrange, we're going to have our y now be equal to y to the power of 2 rather equal to our 4 plus 32, which is equal to 36. Then we take the square root of both sides. So we have this square root of this equal to the square root of 36 plus minus this leaves. So we have our y now be equal to plus minus 6. Okay, so from here, what are the pairs of solution to these very one? So we're going to have here our x, comma, y will now be equal to bracket our minus 2, then comma, plus minus 6. This is also an integer solution. Okay, but it's also accepted. So in all, what are the integer pairs of solution to this math challenge, ranging from our case 1 here, case 2, and case 3? So you can now say therefore, okay, so therefore our x, comma, y will now be equal to the first case here. We have here our case 1 is not accepted, so our case 2 we have 0 comma plus minus 2. So we're going to have here 0 comma plus 2 there bracket 0 comma minus 2. All right, there comma. Then our case 3, look at our case 3 here, the answer to it. So we're going to have this to be bracket our minus 1 comma positive 2 there comma bracket minus 1 comma negative 2 bracket. Then the last one we have this. So this is going to give us here bracket minus 2 comma positive 6. Then the last one we have bracket minus 2 comma minus 6. All right, so these are the pairs of our x and y that will satisfy this original equation. All right, so if you learned something from this video tutorial, give the video a chance up. And if you've not subscribed, do it to subscribe, because here we drop at least a video every day. And when you subscribe, do it to turn on the bell notification button so that the YouTube will notify you whenever we release a good video, a nice video like this one you just watched right now. So thanks for watching. Bye.